All right, so now that we've run our simulation and we know that our circuit and our model is behaving just fine, let's see how we can take measurements in the Simulink model to be able to see the actual performance of the simulation. So if you run a simulation and you don't have a scope, what's called a scope, which we're going to see here in a second, then there's really no way for you to see if the models are behaving the way you want it to behave or the way that you would expect it to behave. So what you need to do is you need to add what's called a scope in addition to some sensors that are specific to your model. So for example, in this case, since we have an electrical circuit, we're going to need a voltage sensor and a current sensor, and then we're going to feed that into what's called a scope to be able to see those signals. So let's go to our library browser and let's go to electrical sensors. And let's go ahead and add a current sensor and a voltage sensor. So what I'm going to do then is I'm going to be able to see the measurements for both voltage across the circuit over here, and I'm also going to measure the current that flows from the voltage source. So I'm going to put my current sensor over here. So what this is doing essentially is it's measuring the current that's flowing. Let me move this down a little bit. It's measuring the current that's flowing out of the voltage source, and it's also measuring the voltage that's in this circuit over here. Now notice here that again I have positive and negative polarity over here for the voltage source, positive and negative polarity over here for the current source, and have this third signal over here. That's the current and the voltage measurement ports. So what I want to do is I want to feed the outputs of those two sensors into a scope so that I'm able to see what the current and the voltage look like in this simulation. So I'm going to go back to the library browser and I'm going to search for what's called a scope. So let me search for that, and that's this block over here. So now let's go back into our model. And what I want to do essentially is I want to see, okay, if this block is measuring the voltage across this capacitor and this resistor, I want to be able to see that in a scope. So again, these blocks are physical signals. So notice that I cannot connect this to the scope because again, the scope is a Simulink signal while this block is a physical signal. So let me get rid of this, and we're gonna need a converter that goes from physical signal to a Simulink signal. Now before here we had a Simulink to physical signal converter. Now we need the opposite. So let's go back to the library browser, and I'm gonna again search for converter over here. And again, I need a converter that goes from physical signal to a Simulink signal. So let's go back into our model, and that's this converter over here. So now notice that I'm able to connect this over here. Now notice that I want both a current measurement and a voltage measurement, but this scope only has one input on it. So one thing that you can do is you can right click on it, go to, let me move this over here. So you can right click on it, go to signals and ports, number of input ports, and change that to a 2. And now that changes the scope such that it has 2 inputs. So now I'm able to connect that to the current over here. And again, I need another physical signal to Simulink converter block. So let me put that over here. And now I'm able to connect, and let me get rid of this. Now I'm able to connect this to this. Now notice what I was saying before, that as your circuits get more complex, or rather your models get more and more complex, now you might have wires that are running on top of each other and your model starts to look a little bit cluttered. So that's why these go to and from tags are very helpful. So what I want to do here is such that we don't have this wire running here through the circuit, I'm gonna disconnect this, and instead I'm gonna use a go-to block. Let me copy that here. Connect it to the signal. I have to change the name of this because all the tags need to have different names. So I'm gonna name this current underscore measurement and hit OK. And I'm gonna use a from tag now and put it over here. And this now is gonna be my current measurement. Now notice that if I go over here and click on this drop down, I cannot see my current measurement over here, and that's because I haven't updated the tags since I added this new tag over here that's called current underscore measurement. So I need to click this update tags, and now this is gonna come up over here, current measurement. And we can also do the same thing for the voltage measurement as well. And let me actually change some of these names because they're pretty long. So I'm going to change this to be, let's say, CTRL and just SIG. So it's CTRL SIG for control signal. And now you'll see here that this gives me a warning that says no matching go-to block. So we have a go-to from here and a from here, but now this is saying, well, you renamed this block over here, the go-to for the control signal, and there's nothing that matches this name, control underscore signal. So we need to fix this. Let's go ahead and do update tags, and I'm going to change this to be this CTRL SIG. And let's do the same thing for this one. I'm going to rename this CUR and MEAS, so current measurement. And now, same thing, we're going to get a warning over here. There's nothing that matches that, so we have to update tags and change this to CUR MEAS. And just for completeness, let's do the same thing for the voltage measurement. So we're going to need a go-to block, but again, we need a Simulink, or rather a physical signal to Simulink converter. So let me put it over here. Let's connect this over here. And same thing over here, it says change go-to block tag because I made a copy of this one. So now I have two go-tos that have the same name, and you can, of course, not have that because now there's a conflict. So I'm going to change this to VOL for voltage. So VOL underscore measurement. And let me move this down and get rid of this over here. So same thing over here. I'm going to change, or rather make a copy of this, and this now is going to be my voltage measurement. And of course we need to update tags first, and let's change this to VOL MEAS. So you can see here why this go-to and from tags are helpful. Again, once we have more and more complex circuits or models, then it's really helpful to have this go-to and from tag so that we don't have signals running all over the place and potentially running over other things in the model. So it just helps make things a little bit more organized. So let me actually move this here to the left. Again, there's essentially a virtual connection between this and this, between this and this, and between this voltage measurement and this voltage measurement over here. Now, we're ready to simulate and see how our signals perform. Let me change this simulation time to 3 seconds. So I just want to measure the current and the voltage for only 3 seconds. And we could either run that from here. So again, this is what we did before. We can simulate the model from this run button over here, or we can actually open this scope, and there's also a run button over here. So let me actually hit run from here, and again, this does the same thing as this run button over here. These two buttons over here, this one and this one, are just the same thing. Right, so here now we see two traces. We have this yellow one and this blue one, And that's because we have two inputs to our scope. Now, one thing that you can do to split those two between different axes is you can go here to View, Layout, and select this view. So two windows, one on top of each other. So we have two signals coming in, the voltage measurement on the top and the current measurement on the bottom. And now we have here the voltage on the top and current on the bottom. So you can see here again that what we were trying to do was, and let me move the scope over here. So we have the simulation time over here. We're simulating for 3 seconds. We're scaling that by 5, and that's what we're feeding into this controlled voltage source. So again, at t equals 0, then the output of this clock is going to be 0. We're scaling that by 5, but 0 times 5 is still 0. So the input to the signal over here is going to be 0, meaning that the output of this voltage source is also going to be 0. At t equals 1, then we're scaling that by 5, so that's a 5 on this signal over here that comes over here. And now we're feeding 5 into this control input to the voltage source. So the output of the voltage source then at t equals 1 second, we would expect that to be 5 volts. Let's see if that matches the simulation. So we have time over here at the bottom. Again, notice here that we have 3 over here, and that's the same as our simulation time. So this is 3 seconds worth of simulation as if this circuit was in real life. So again, voltage at the top, that's given by this block over here. Current at the bottom, again, that's given by this block over here. And we can see that at t equals 0, the voltage is equal to 0 volts. Again, this measurement comes from here. At t equals 1, we would expect that to be 5 volts, and we can see that over here. Let me actually make this a little bit bigger. So at t equals 1 second, which is this over here, we can see that the voltage is 5 volts. So we have 5 volts over here, and if we move that to 1 second, that matches over here. So 1 second, 5 volts. And again, we would expect then at 2 seconds, so 2 times 5 will be 10 volts. So we would expect at 2 seconds the voltage to be 10 volts. Let's see if that matches. So this is 2 seconds, and it's at this point over here. If we see what that's on the y-axis, that's equal to 10 volts. So that matches. And then lastly, 3 times 5 would be 15. So this time over here, we would expect that to be 15, and it sure is. So again, this trace over here is the voltage, which we're using this control voltage source for. And basically we're feeding the clock, so the simulation time times 5, and that's what we would expect the voltage to be. So we would expect the voltage to be at any given time 5 times the simulation time. So 5 volts at 1 second, 10 volts at 2 seconds, and 15 volts at 3 seconds. Now this trace over here at the bottom is the current that flows through the circuit. So we have a current sensor over here. We're feeding that to this go-to block that's coming over here. And then we're also feeding that to the scope. And same thing, because the voltage is going up, we would expect the current to also go up. And of course, the magnitude of that depends on the values of this resistor, which is 10 ohms, and this capacitor, which is 1 millifarads. All right, so I think that's a thorough explanation on how to build a model, how to manage signals, how to run simulations, and then lastly, in this lecture, we saw how to take measurements to see if the circuit is performing the way that we would expect it to. In the next lecture, we're going to see how we can define MATLAB functions within Simulink, and then we're going to move into some projects that are going to be a little bit more complex, or actually quite a bit more complex than this circuit that we've built over